In this section, we're going to talk about problem solving and different techniques we can use to solve problems. George, I think you say this Pólya, but I could be wrong, established a 4-step problem-solving process that can be employed in any situation, not just math, any situation. This process is especially helpful when solving problems involving mathematical concepts. So first, you want to understand the problem. Read all the information, identify key information, and maybe take out anything that you don't need, and identify and understand what's being asked. Develop a plan. Determine the best problem-solving strategy that fits the problem. So there's several different types of strategies you could use that we'll be going over, like find a pattern, adopt a new point of view, solve a simpler problem, work backwards, draw a picture, guess and test. Use logical reasoning, use a variable, or account for all possibilities. That would be hard. Carry out the plan. Use the chosen problem-solving strategy to perform calculations, and then look back and see, is my answer feasible and correct? For example, sometimes I'll get students who will tell me, say, I give them a problem and say, okay, a shirt is $20, and there's a discount, or you have to add tax of 6% to that, and they'll come back to me and say that the answer is $3. And I'm like, wait a minute, that doesn't make sense. You're added tax to the $20. So your shirt would have to be more than $20 at the end. It's not going to be less. So always think about whether your answer makes sense. And if it doesn't, go back and see where you messed up or what you need to add on. What worked? What didn't work? Will the solution to this problem assist me in the next time I see a similar problem? Example 1. We're going to work backwards on this one. It says, while 3 watchmen were guarding an orchard, a thief slipped in and stole some apples. On his way out, the thief met 3 watchmen, one after another, and he was trying to bribe the watchmen, I suppose, into not turning him in. So to each in turn, he gave 1/2 of the apples he had, plus 2 more in addition to that. In this way, he managed to escape with 1 apple. How many apples did he steal originally? So working backwards, we know that he escaped with 1 apple. Then we're going to look at, for the 3rd watchman, what would we have needed to do? It says that he gave him, the 3rd watchman, 2 apples plus double what he had. So he had to have given the 3rd watchman 6 apples. Back when he was at the 2nd watchman, he had those 6 apples that he gave to the 3rd, plus 2, and twice that, he had given the 2nd watchman 16 apples. Or he had 16 apples when he gave the 2nd watchman apples. So at the 1st watchman, he had 16 plus the 2 he gave the 1st watchman, plus the double. So he must have started with 36 apples. Example 2, arrange the numbers 1, 2, 3, 4, 5, and 6 in the circles of the given triangle such that the sum along each side is 12. Okay, so the first thing we want to do, we're just going to guess and test on this. Because there's not really a better way to do it. But I don't think it'll be too difficult. So, first of all, let's see what numbers would add to be 12 out of 1, 2, 3, 4, 5, and 6, okay? Well, 1, 5, and 6 would add to be 12. And let's see if there's any numbers that only use one of those numbers above. So if we use 5, because we're making a triangle, you'll see why I did it in a second. If we use just 5 above, are there any other two numbers that would add on that would give us 12? Yeah, if we use 4 and 3, that'll give us 12 also. So let's see. Let's start our triangle. 1, 6, and 5. And then 4 and 3. So what we need to do here, we know that this adds to be 12. And we know that this adds to be 12. We need to see if we put in the other number, will this one add to be 12 with this row here? So what's the other number? That would be 2. 1 plus 2 plus 3 is 6. So this one isn't going to work. So I've moved that one over to the side so we know one that doesn't work. Let's try rearranging those numbers here. So instead of 1, 6, and 5 down the side, let's try 6, 1, and 5. Okay. And then we know 4 and 3 could go here. And we put in a 2. 6 plus 2 is 8, 9, 10, 11. That doesn't quite cut it. So let's just switch that 4 and 3 and see if that helps. Because so far this way we've got 12. This way we've got 12. If we put a 2 in here, 6 plus 2 is 8 plus 4 is 12. So we've got it. Find the sum of the numbers 1 through 1,000. Oh my goodness. That would take a long time. So, what we're wanting is 1 plus 2 plus 3 plus all the numbers 998 plus 999 plus 1,000. All the way, right? Well, a mathematician named Carl Gauss solved this problem over 200 years ago without a calculator. So we're going to do it like he did it. Let's see. He's considered a simpler problem, like adding the numbers 1 through 10. So 1 plus 2 plus 3 plus 4 and so forth, all the way up to 10, comes up to be 55. Or 55 is 5 times 11, right? Or we could also say this as 5 pairs of 11. In other words, saying it as 5 pairs of 11, what we're doing is saying 1 plus 10 is 11. 2 plus 9 is 11. 3 plus 8 is 11. Notice how I'm going in 1 each time. Okay? So we want to do the same thing with 1 through 1,000. So starting with 1 plus 1,000. Instead of 1 plus 10, we're using 1 plus 1,000. We should get 1,001 instead of 11. Okay? Then we would do 2 plus 999 gives us 1001. 3 plus 998 gives us 1001. All the way down to, we would end up with 500 plus 501 gives us 1001. Well, you could say, well, this isn't helping us a whole lot. All it's done is cut our work in half. We still have to add up all of those in the middle. Well, no, we don't, because we know that there's going to be 500 of these. 1, 2, 3, 4, 5, 6, all the way up to 500, right? So there's going to be 500 pairs of 1001. That would be 500 times 1001, which is 500,500. That's what the sum of all the numbers of 1 through 1,000 are. A lot simpler than trying to add them up. Your uncle gives you $1 on the day you're born, $2 on your first birthday, $4 on your second birthday, and so on, doubling the amount on each birthday. How much money does he give you on your 18th? So let's look for a pattern. First, he gives you $1. The next year, he gives you $2. The next year, he gives you $4. Do you see a pattern here yet? Well, we're not adding 2 each time. We're not adding 1 each time. Let's see. 1 times 2 is 2. 2 times 2 is 4. I think they needed to... So they're multiplying each time. And what that actually is 2, like 4 is 2 squared. 2 is 2 to the first power. 1 is 2 to the 0th power. So the next amount you would get would be 2 to the 3rd power, which is 8. For your 4th birthday, you would get 2 to the 4th power. That's 16. So for your 18th power, your uncle would give you 2 to the 18th amount of money. That's $262,144. I sure hope you've got a rich uncle. A baseball league is forming in which each of the teams will play 4 games against each of the other teams. There are 5 teams in the league: the Raiders, Jackals, Blazers, Warriors, and Eagles. Determine how many total games will be played. Well, we could set this up by doing a diagram. We've got the Raiders, the Jackals, the Warriors, the Blazers, and the Eagles. It doesn't really matter how you put that. I just did it that way. So we could just start drawing and count. So the Raiders would play the Warriors, the Jackals, the Eagles, and the Blazers. It says they play 4 games against each of the others. So that would be 4 times 4, or 16 of the games there. Then the Warriors, we don't need to draw a line back to the Raiders because they've already been drawn. So they'd play the Jackals, the Eagles, and the Blazers. So that's 3. For 3 games is 12. And then the Jackals, again, don't repeat your lines, so we just go to the Blazers and the Eagles. So that's 4 times 2. And last, just the Blazers and Eagles. So that's 4 times 1. 4 times 1 is 4. Sorry about that. Okay, so if you add all those up, you get that they played 40 games. How many ways can you make change for 50 cents out of quarters, dimes, or nickels? Let's make a list. So we have quarters, dimes, and nickels. We're going to see all the possibilities here. And just in case I need some extra space, we'll go ahead and make another little table to put here. Okay, so let's start with quarters. You could have 2 quarters to make 50 cents, right? You would have 0 dimes and 0 nickels. Okay? You could have just 1 quarter. That would give you 25 cents. And if you have 1 quarter and 2 dimes, that would give you 45 cents, then you would just need 1 nickel. What if you had 1 quarter and 1 dime? Then that would give you 35 cents. You need 3 nickels. What if you had 1 quarter and no dimes? Then you would need 5 nickels. So you see our process here, we're just kind of going down with each one. So let's see if we had no quarters. If you had no quarters, you would need 5 dimes and no nickels. Again, no quarters. Let's say you had 4 dimes, then you would need 2 nickels. No quarters. Let's say you had 3 dimes, then you would need 4 nickels. No quarters with 2 dimes, you would need 6 nickels. No quarters with 1 dime, you would need 8 nickels. No quarters and no dimes, you would need 10 nickels. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 combinations. A number is multiplied by 8 and the product is added to 6. What is this number? Oh, it says if the sum is 30, what is this number? Okay? So for this one, we're going to use a variable. Let n be our unknown number. So it says the number is multiplied by 8, and that is added to 6. And that sum gives us 30. So we can find the number by solving for n. Subtract 6 from both sides. And divide by 8. The number is 3. And I believe that is the end of the section.